In this video, we're going to continue talking about section R.4, which is polynomials, okay? And so the last time we worked our way up from one term, which we called a monomial, and right at the end of the last video, we talked about two terms, which is a binomial, and then three terms, which is a trinomial. And then after that, we can just say many, which is poly. And so we have polynomials. So a polynomial in one variable is an algebraic expression of this form. And so you'll notice that it has x to the n, but it has a number of different subscripts. Okay, it's basically a possibly infinite number of monomials added or subtracted together. Okay, it's a polynomial. And so you'll notice, and it goes through this, all the a's are constants, and they're all coefficients, okay, of the polynomial. N is an integer, which has to be greater than or equal to 0, so it has to have at least a couple of terms, is basically what that's saying. And if an is not equal to 0, so if this out in front is not equal to 0, then it's called the leading coefficient because it's in front. Okay? Usually they're going to be ordered from largest degree down to smallest degree. Okay? That's how polynomials will be presented. And so an will be the leading one, so it's the leading coefficient. Okay? The whole term together, all this is called the leading term, and of course the n is the degree of the polynomial. Okay, so the degree of a polynomial here is the largest degree monomial. Okay, so here are a number of different examples. Okay, so for instance, in the first one, here I give the polynomial here, and then I ask for the coefficients, where they give the coefficients, and so you'll see there's the four numbers, -8, 4, -6, and 2, okay? And then the degree of the polynomial, which we put, which there's only one degree, okay, is the degree of the largest monomial. So we see that's 3 here. Okay? So there's that. And then we go on, it goes on to give a number of different ones. And they all have sort of different things, okay? This isn't, when they write them, like, for instance, in number 2, I'm not trying to solve an equation for 0 here. What they did is they're looking at this polynomial, and to help you, they put in the missing term that's not visible on the left. Okay? But anyway, so you can go through those, try to reason through, check it out, see if everything makes sense there. Right? And an important point is that although I've shown always polynomials in terms of x here, all of the examples I show over here are in terms of x, these can be in terms of any letter. Usually we'll use letters at the end of the alphabet, so X, Y, or Z, okay, but they can be really anything. So it's just an important point to keep in mind. Now, we've seen a lot of examples, if you look before in the previous slide, of things that are polynomials. But polynomials have very specific forms, and there are also things that are not a polynomial. Okay, and so these are examples of possible equation, function, expressions, maybe it's the right word to call them, that are not polynomial expressions. Okay? And so we'll look at each quickly. 1 over x is the first one. And you may or may not know that you can rewrite 1 over x as x to the negative first power. Okay, you can rewrite 1 over x as x to the negative first power. And so you might say, well, that looks awfully like a monomial. You have to pay attention to the definition of a polynomial or monomial. It says that the degree of the x has to be non-negative, which means greater than or equal to 0. Okay, so -1 is not, so 1 over x is not a polynomial. Next, over here, I've got x's in the top and the bottom. So if you look at the top of the fraction, x squared plus 1 is a polynomial. And in the bottom, x plus 5, that's also a polynomial. But when I divide two polynomials, that doesn't necessarily mean that I'm going to get a polynomial back. Okay, and so if it doesn't simplify to something that looks like this, which doesn't have any fractions involved in it, then it's not a polynomial. So that's not a polynomial either. This next equation, or this next expression here, is e to the x. Now we may not have gone over, you may have never seen e before. It's a mathematical constant. And you may wonder what the heck that is. We all know what pi is. Pi is like 3.14159, so on and so forth. That's also a mathematical constant. So e is just a number that's special in the mathematical world, just like pi is. And so I have a number raised to the x power. And that causes a problem because I need the x not in the exponent, okay, but down where the e should be. So that's also not a function, because if you look back here, the x's need to be not in the degree space, or the exponent of that expression. And then the last one, which is something that you may also not have seen before, but we will talk about near the end of this course, is something called the natural log or logarithm of a number. Okay, that's what ln stands for, natural logarithm. And it also does not have this form, because all that we can do to the x's are multiply them by a number and then put an exponent on that number. We can't do anything else. And so taking the natural log right here, taking the natural log is a non-polynomial thing to do. Okay, so all of these are examples of non-polynomials. So we do need to have a specific form of what we're looking for. Now, let's get to adding and subtracting these polynomials. All right, so polynomials are added and subtracted by combining like terms. Okay, and so here's a fairly simple example. Okay, that I'm going to do two different ways in hopes that one of the ways will sort of resound with you, and that can be your go-to way to do these problems. So I want you to add, or what we're looking at is 8x cubed minus 2x squared plus 6x minus 2 plus 3x to the fourth minus 2x cubed plus x squared plus x. Okay, those are the two things that I'm adding together. And when I do that, I need to, as it says, combine like terms. And so we see what are like terms here. Well, I have an 8x cubed and negative 2x cubed. As we learned before in the last video, like terms are when you have two monomials that have the same variable, x here in this case, and that variable is raised to the same power, which in this case is 3. So I can combine like terms. Okay, and so I could do 8x cubed plus negative 2x cubed, right? And so on and so forth. And so if we always want to write the largest degree first, we first have to look at 3x to the fourth. Does it have any like terms? No, it doesn't. So we're going to rewrite that here. 3x to the fourth. Okay. And then we do the x cubed stuff, which I detailed just a second ago. And what we're left with is plus 6x cubed. Okay. And so that gets rid of this and these two. Then we have negative 2x squared and positive 1x squared. And so we're left with minus 1x squared. So that gets rid of the squares. Then I have plus 6x and plus x. So 6 plus 1 is 7. 7x. And then is there anything left over? There's this minus 2, but there's no just regular number on this right one. So we're left with minus 2. And so that's the answer there, which is not too bad. But another way to write this is sort of vertically. Okay? And so I'm going to write these two in a vertical manner. And so you'll see what that means here. And so I'm going to write actually the second one first, because I can addition, order doesn't matter. So I'm going to write the second one at the top. Or actually, no, never mind. I'll write the first one just like I would write any equation. 8x cubed minus 2x squared plus 6x minus 2. And then I'm going to add, in this vertical direction sort of way, the other polynomial. And I'm going to do it in a special way where I want my like terms to line up. And so I'm going to draw a little demarcation line there. And really what I have are places. And so maybe I'll draw a dotted line down each of these sort of imaginary places. To the right, I have the x to the fourth place. Then I have x cubed place, x squared place, x's place, and then just numbers place. Okay? And so then I rewrite, or I write this second expression here into this format, box format. And so I have 3x to the fourth is in the x to the fourth place. Negative 2x cubed is in that place. Positive x squared is there, and then positive x is there. Nothing is on the end. And I know this picture is crowded, but I add then downward. There's nothing in 3x to the fourth, so 3x to the fourth. 8x cubed minus 2x cubed is positive 6x cubed minus x squared plus 7x minus 2. And so lo and behold, I get to the same answer. Up here, this is what they call the horizontal sort of strategy, and then this down here is the vertical strategy. So you can choose either way to do that. They both work just fine. Do whatever makes the most sense to you. Okay, so now we're going to subtract these two polynomials. This gets a little more complicated. Okay? So we have 3x to the fourth minus 4x cubed plus 6x squared minus 1. And then I'm subtracting the other expression. Okay, so I write that all out. And what I can do is distribute this negative to each of these sort of monomials in that polynomial expression and turn this into an addition problem. So I'm going to do that. This is, again, the horizontal sort of way of thinking about things. 3x to the fourth minus 4x cubed plus 6x squared minus 1. And then we have minus 2x to the fourth plus 8x squared plus 6x plus 5. Oh, sorry. This should be a plus up here, and thus a minus down here. So now I have sort of an addition problem that I can work with, okay, and I combine like terms. So I'm left with x to the fourth after canceling out this and this, minus 4x cubed because there's no x cubed term in that second half. So there goes that. 6x squared and 8x squared gets me positive 14x squared, which gets rid of that and that. I go next to the just x's. There's only one of those. Plus 6x, and then minus 1 and minus 5. We get minus 6 at the end. And so there is the answer. Okay? You do the same thing, same sort of strategy with the vertical addition, and now would be subtraction. Okay? For the vertical strategy, you want to make sure to do the distributing of that negative first. Okay? So, last thing that we're going to do is multiply polynomials. So I know this is a long video, but these are sort of the basics of polynomials, so it's important to get it correct. Okay? Now, when you multiply polynomials together, you do more than just combine like terms. And so you use the laws of exponents to solve these sort of problems. So when you multiply two monomials together, or these are monomials but also polynomials, the numbers out in front multiply, and so 2 times 5 is 10, and then the exponents of the like variables add together. Okay, so I have 2 times 5 gives me 10, and then I have x cubed times x to the fourth. And by the laws of exponents, I could rewrite that as x to the 3 plus 4 power, which gets me x to the 7th power. And so that's how I got 10 times x to the 7th. Okay? And now to get in a little more tedious example, tedious or complicated, whichever way you want to think about it, we have a binomial, 2x plus 5, times a trinomial, x squared minus x plus 2. Okay? And so what we want to do here, we're sort of getting into what you know as sort of like FOIL land, okay? But it's a little more complicated than FOIL. You want to use the distributive rule for each term of the binomial. Okay, you want to distribute each term of the binomial, so that would be 2x and 5, each to the three things in the trinomial. So you could rewrite this as 2x times everything in the trinomial plus 5 everything in the trinomial. And if that makes sense, try thinking about it like this. Okay, you know, this may make it more complicated, but I hope this helps. Instead of trying to think about it all at once, try to think of this as just one thing. I'll call that A. Okay? And so if I have 2x plus 5 times some quantity A, what would happen is I distribute that a to both the 2x and the 5. But here, a is really x squared minus x plus 2. So that's essentially what I've done down here, is I've distributed that trinomial to each term of the binomial. And so now we can use the distributive rule again to get us down to sort of simplest monomial terms. So the 2x is going to go to all three terms. And so you get 2x cubed minus 2x squared plus 4x plus each, the 5 goes to each, plus 5x squared minus 5x plus 10. And again here, I'm now into an adding and subtracting polynomial setup. You combine like terms. So 2x cubed is left alone. Minus 2x squared plus 5x squared is plus 3x squared. So that goes plus 4x minus 5x is minus x. And then lastly we have plus 10 there. And so then that is the answer. Okay? So that's multiplying polynomials. So here is your turn. So I give you two examples or two tasks here. Each of them involves some distributing and then adding and subtracting. Okay, so this first one is going to be more on the adding and subtracting side. The second one is going to be just like what we did in the last slide. Okay, that's the end of this video.